Hello everybody. In this video, we are going to continue solving another problem from LeetCode's top interview 150 problem list. So far, we have done all the problems up to product of array except self. If you haven't checked out my videos on those problems, please go to my channel and check them out. So today we are going to try to solve this problem, gas station. Let's read the problem and make sure we understand it. There are n gas stations along a circular route where the amount of gas at the ith station is gas of I. You have a car with an unlimited gas tank and it costs cost of I of gas to travel from ith station to its next I plus first station. You begin the journey with an empty tank at one of the gas stations. Okay. Given two integer arrays gas and cost, return the starting gas station's index if you can travel around the circuit once in the clockwise direction, otherwise return -1. If there exists a solution, it is guaranteed to be unique. Interesting. I have to read that again, I have to admit. I think I half understood it, but let's read it again to make sure. So there are n gas stations. Okay, they are in a circular route, so they are kind of placed on a circle or something like that. And we are given we are given gas at each of that station that is available, so we can fill that much in our car. And we are given the cost, and cost here isn't the initially I thought the cost at I station means when I buy gas I pay that much money. That's not what cost is. I realize that the cost here means how much gas will be used if we start at station I to reach station I plus 1. So that's what cost here means. Okay, so that's one thing. Yeah, so from I to I plus first station, the cost word just threw me off a little bit. And then you can begin the journey. We begin the journey with empty tank. Okay. And then basically we can start from any gas station with an empty tank. Okay, so here is what I understand. So there are gas stations. Actually, let me try to draw this. It's going to be tricky, but okay, let me draw a circle, right? So there are gas stations on a circular route, right? So I don't know if this will be allowed, but let's try it. So let's say there is a gas station here. That's really big. I don't need it that big, but one sec. Yeah, let's pull this dude down. Yeah, okay. This should work. So let's say that actually I'm going to write gas and cost for each of them, right? So let's take this example. 1, 2, 3, 4, 5 and 3, 4, 5, 1, 2. Okay, that's an easy thing to remember. So the gas available at station 1 is 1 and the cost to go to station 2 or the next station is actually 3. So let's say that is, let's say that dude is right here on the path. Okay. I know this will take a bit of time, but I think it is going to help us understand the problem really well. Okay. So the gas at the second station is, I think it was 4, I think. Yeah, 4. Yeah. Yeah, I think it was 1, 2, 3, 4, 5 and 3, 4, 5, 1, 2. Yeah. So that's 4. And then the gas at the third station is 5. Sorry, the gas is 3, but cost is 5. So gas is 3, cost is 5. Yeah, I'm not going to try to draw some equidistant. It doesn't matter. And then the fourth gas station has now 4 and this is 1. Yeah. And then the last gas station has 5 gas and this is 2. Yeah. So I think this is kind of one example. I think it's fine. It's not the best diagram I've drawn for sure, but it still works, right? Okay, so let's see what they are saying in that example. So in that example, sorry, not this time. Okay, So in that example, let's see the explanation. If you start at station 3, index 3, oh, so the correct output is 3, I see. And fill up with 4 units of gas, then your tank will have, yeah, it starts with 0, so 4. Then you travel to station 4 from there, so you get 4 minus 1, but you fill 5. So okay, I think that makes sense. Okay, so what they're saying is, let's say if we start from here, it doesn't work, right? Because right away we start with gas tank empty, so we only will be able to fill one, but then it will cost us, let's call it 1 gallon, doesn't matter, 1 gallon, and it costs us 3 gallon to reach the next gas station. So that cannot be the valid start place, and we cannot finish the circuit because we can't even reach the next gas station. Here we same thing, right? We have a deficit of 2 basically, so we can't really do it. So wherever there is a deficit, we can't really start there, right? uh, and then the next one, same thing, a deficit of 2. Finally, we have a thing without the deficit. So yeah, we can start there, and we'll basically have a surplus. When we reach here is when we will have 4 minus 1, 3 gallons. Then we again fill up 5, right? So we have 3 plus 5, 8 gallons, but we use 2 gallons to reach there. So we have a 6 at this point. Out of 6, we will use up 2, right? 3 minus 1 is 2. So we'll have 4 when we reach here, and out of 4 we'll end up using 2, and then we'll go here, and out of 4, yeah, and then we'll actually reach with 0, literally 0 left at the go back, right? So we finish the circuit. Okay, so that's why the answer in this case is this gas station, which is index 3, 0, 1, 2, 3, right? Okay, finally understood the problem. Okay, so and then they have the second example where if we have 2, 3, 4 and 3, 4, 3, there is no way to make a circuit no matter where we start. Well, the first one cannot work because it has a deficit of 1. Second one cannot work, a deficit of 1. Third one has a surplus of 1, but then it cannot make up for the deficit, right? Which is a total of 2. Okay, so that is another important thing for us to note, which is the that probably is actually obvious, right? The sum of gas should be greater or equal to the sum of costs, right? Otherwise, we cannot finish the circuit, and that's pretty obvious, right? So in this case, if we sum up the gas, then it becomes 9, while the cost is actually 10, and that's why. And then that's, yeah, we are one short, and that's what we just noticed. Okay, so there's a second example. Okay, so let's look at the constraint. Well, n is, yeah, the length of both the arrays is the same, and that's called n. And then the length of both the arrays is between 1 and 100,000 inclusive. Okay, sure. And then the values of, in both the arrays are between 0 and 10,000 inclusive. Okay, so those are the things. Okay, let us think of an approach. It's a very interesting problem. Well, I mean, anytime we look at such a problem, we should always not be shy, especially in an interview, to just give the simplest of the solution, right? And simplest of solution is we try all starting gas stations, right? And we see if it works, right? And so what I mean is, again, drawing it in kind of the ASCII characters here. Like, let's take that same example, right? 1, 2, 3, 4, 5 are the gas values. The cost values are 3, 4, 5, 1, 2, I think. Yes. Sorry about that. Let's also write the indices here. Indices are 0, 1, 2, 3, and 4, right? Those are the indices. I'm just going to actually call them I colon, right? Okay. Okay, so what I mean is we try all the starting values, right? We say, okay, actually let's wrap around as well, just to, not sure if this is strictly needed, but just to, so in order for us to finish the circuit, there should be, the whole route should contain all the gas stations, right? Which is in this case 5. So let's wrap around 4 more elements, right? So 1, 2, 3, 4 are the indices of those, and we have 1, 2, 3, 4. Sorry, we just need 0, 1, 2, 3, and then we say 3, 4, 5, 1. And the reason I wrapped around is to kind of show what are the various things we need to consider, right? So we consider 0 to 4, right? And say if that works, or we say, does this work, which is, one sec, yeah, just for it to be same length. And then 0 to 4, we say, does this work, which is 1 to wrapping around to 0, right? Or does this work, which is 2 to wrapping around to 1? And does this work, which is 3 to wrapping around to 2? And does this work, which is 4 to wrapping around to 3, right? So we try all of those and we see if we can actually do it, right? And that would be an O of n square algorithm, because for each of these, we'll have to scan the array and do it. And we could also implement it, like, I think it's pretty straightforward, but especially if it is an interview and we are not sure if we will be able to, come up with a better algorithm. Not sure if there is, but in such problems, generally there is, right? Then it's not a bad idea to implement it. Maybe not right away, so that leaves you enough time to figure out the, problem or the final solution or the more efficient solution. So maybe spend, some time thinking about a better algorithm. But if it is feeling like you are not able to figure it out, then at least write the code for the naive approach. And sometimes writing code for the naive approach actually helps us get to the better approach, right? Sometimes just the naive algorithm is enough, like this one is enough, right? So, okay, so in this case, I'm going to, not sure if it's a wise idea, but I'm going to spend the time to write that approach. Okay, so let's make some more space. So what are the various things? So we have various start values, right? We have I equal to 0, I less than gas dot length plus plus I. Okay, so for all those start values, we need to kind of run a loop and sum up the gas and the cost, right? So we say int j equal to I plus 1, j is less than, actually, what we should do is we should just say, yeah, j is less than I plus 1 plus gas dot length. We'll just do modulo inside, right, for wrapping around, right? And then what are we doing here? We are actually here, sorry, for each iteration, we are calculating the total, right? Or net gas, rather. Let's call it net gas, right? Okay. And what are we saying is, the index, first of all, is equal to j percentage gas dot length, right? Okay, and then what we are saying is net gas plus equals gas of I minus cost of I. So we add what we can fill up and we subtract what it's going to cost us to go to the next one, right? And then we say if net gas is greater or equal to 0, then we return that I is the starting index, right? Actually, in this case, we should not be doing I plus 1. We should be starting with I, right? And sorry about, I just noticed I plus just gas dot length, right? Because we should be starting at I, yeah. Okay. So if that is the case, then I is our starting gas station where our net gas would have been fine when we came back, right? And if none of it returns, then we return -1, right? None of it actually has net gas greater or equal to 0. So this would be like a naive implementation. I just implemented these like, sliding, various sliding window kind of a thing. Okay, so let's just do that. I'm very sure this is like a pretty inefficient approach, but again, just to, kind of demonstrate. Let's run it and hopefully it works, right? It's a pretty straightforward. Okay, compiler is fine. Oh, I just gave the same name. Seriously. Okay. All comps, right? Or all starts. And then I'll just copy paste that. There you go. Wrong answer. Okay, let's figure out why we got the wrong. Oh, it got the wrong answer in the case where we were supposed to. Oh. Okay. Actually, no, that's not true. I thought I wasn't initializing to 0 and then it was accumulating from previous ones. But, oh, this is I. Okay. This is the fun of live coding, right? We have to do index here. That's what it is. Let's see. In the other case, it actually accidentally worked, which is interesting. Okay, that also did not work, and now that we broke the first test case. Let's see what's going on. Okay, let's go a bit slow. So starting 0, then j is I plus gas dot length. Yeah, that is, oh, we need to start, yeah, we start from I and we go from, yes, that makes sense. Index is j percentage gas dot length. Net gas is plus or equal to that. Oh, you know what? We actually need to check whether the net gas is negative at any point on the path, right? I don't know if that is what failed the first case though, but let's do that. Because here like net gas will always be 0 or 4, right? So in fact, what I need to do is if net gas is less than 0, then we break, right? Because it has to be continue to be positive. And then here outside the loop, if the net gas for that one remained positive throughout, then that could, how will that be indicated? Let me think about that. So net gas is equal to 0 and it kept on remaining. Yeah, so I think this is still the right thing to do. Like if it was negative and we broke out, then we do not return that, right? But if it was positive throughout and we broke out, then we basically return that. Okay. I thought it would be straightforward to implement, and that's why I tried it. But apologies that it took a bit longer. Okay. So, well, I did want to add a couple of test cases here. So, for example, exactly the bug that we had, right, which is I mean, which it already failed one test case, but for example, if it was something like you go to 1, 2, 3, 4, 5, yeah. So what I was thinking is, let's say that it becomes up to this index, it was negative, right? And then our answer was actually this index. But let's say that is positive, and then it becomes negative. Then it goes into deficit again. So here we have a net positive of 3. So we start with that index. So far it works. But what if here we spend all of that by doing 9, right? And then let's say 6 is a better start. So 6 is again positive, and then it gives 1, and I think what is left? I think we have 2 left here, 2 left here, deficit of 2 here, surplus of 3. So that's 6 minus 3. So still a deficit of 3. Then a deficit of 4, so another 7. So we made up 1. So we have to make up 6 more. So this should work with an answer of this index, right? So that's the test case I want to run. Oh, cool. And oh wait, -1. Why? I was expecting, did I construct it? Oh, sorry, the gas has to be more, 6 more. So this was this way, right? So the gas has to be 6 more. I made the cost more, of course, then we can't make it. Okay, so yeah, so that is what I was expecting. So index phi is the answer, 0, 1, 2, 3, 4, 5. So this is the place where it actually works, otherwise it doesn't work. Okay, cool. Now let's figure out a better approach, right? Well, I mean, one thing to repeat from before is that the total of the gas has to be more than or equal to the total of the cost, right? So let me actually just take that example here again. The example is that, let me just copy paste this, sorry. I don't think in this case we need wraparounds. Maybe we do actually. Let's keep the wraparounds for now. Okay, so that's our example. And so the total of gas has to be greater or equal to the total of cost. So that's fine. But okay, so one thing is clear, right? Whenever there's a negative deficit at a specific location, that cannot be the start. So that's fine, okay? Actually, what I want to do is actually, let's remove the wraparound and take the other example I took. Because there deficit becomes positive, but it's still not the right answer, and there is an answer later on which is the right answer. So we have 2 more, I think, and then let me just pull up what I had added there. Okay, 1, 2, 3, 4, 5, 6, 7. So we have 6 and 7, and then here we had, I think I changed 1 to 9. Yeah, 9, 5, 1. Okay, so this is 9, 5, and 1. Okay, so in this case, the reason I like this test case to come up with the algorithm is that even though at 3 the deficit is positive, that's actually not the right start because it becomes negative later. Anyway, so in that case, okay, so 3 is a potential start. So we'll skip this, we'll skip this, we'll skip this, but 3 is a potential start, right? And the net gas at that point is 3. But here the net gas again becomes negative. So we can reset our start to it's not 3 anymore because it will get stuck at a couple of gas stations later. And it is not this anymore, but the start is actually potentially this, right, at this point. And then we go there and then, okay, so that is probably the algorithm. I think one more, yeah, so what sorry, I'm going a little bit too fast, but okay, let me demonstrate it here. Actually, this is better because this is a better example. We don't need that diagram. Let's do it here. So what I'm saying is initially we keep track of net gas. Okay, net gas is our running net gas. Okay, and we loop through the whole array. If and we adjust net gas, right? We add gas to it. Actually, let me just do this equal to net gas plus, but we subtract cost from it. And if net gas becomes less than 0, then we have to say our start is potentially the next cell. It's not the start that was previously potentially the start. It is actually the next cell, right? So we have start equal to the next index, right? And we reset net gas. Sorry, we have to reset net gas. So, well, generally in pseudocode, we don't use curly brackets. What we say, net gas is 0, right? In pseudocode, we assign 0 like that, by the way. But anyway, you get the point, right? So we do that. And outside the loop, I mean, we do this for each index, right? So to be very precise, for each, right? This is all inside, so that's that. But outside the loop, we still need one check, right? And that is the total of the gas greater or equal to total of the cost, right? Only then we return that start. Otherwise, we return -1. So if total gas is greater or equal to total cost, right? Then we say return start. Initial value of start should be 0 here, right? But start is 0 because that's a potential start, right? Okay, and then otherwise here we return -1, right? I think this should work given what we observed about the fact that total has to be more and the fact that hey, a starting position could become, even though at that point it's a good start because net gas is positive, it could become worse later, and then in that case, that will be taken care of by this if condition. Okay, let's try to code that up. One second. I actually still somehow feel like we are missing something, but maybe not. Okay, so let's see private int, and let me just copy paste the signature here and call it like fast, like we sometimes do in such cases. Okay, so what's our approach? Well, we are keeping track of net gas, okay? And we are keeping track of start. Start is 0. And then we are actually, for each element in the gas and cost array, what are we doing? We are saying, okay, first we are saying net gas plus equals gas of I minus cost of I, right? So, okay, so we calculated our net gas, and if that became less than 0, which is negative, then we say start equal to I plus 1. The next one is the start, not us, not where we are now. Potentially the next one isn't, but then the next loop iteration will take care of that, right? And then we say net gas is equal to 0. We need to reset it to 0 so that the next location can consider itself the start, right? Okay. And then here, oh wait, so we also need to total up the whole array, right? So we can do it in the same way. So total gas equal to 0 and total cost equal to 0, right? And we just add them both up. Running total for both, right? So total gas plus equals gas of I, total cost plus equal cost of I. And then here, so here is where we return, yeah, here, right? We say return if total gas is greater or equal to total cost, or actually, I mean, we can do the opposite, which is if it is less than return -1, otherwise we return start, right? And start could in some cases go beyond the length of the array. So but in that case, that would only be if total gas was actually less than total cost, right? So we could construct an example where start would be, for example, if the array is of size 5, start would actually be 5, which is not a valid index. But we would never end up returning that because of this condition here. Because if there existed a start which was valid, we would have actually not done that. Okay, so let's see if, okay, sorry about that. Okay, and let's try to run that. I'm really nervous about this one. The compile error, I'm not nervous about. Oh yeah. Let's see. Oh, cool. It did accept it, and even this got accepted. Okay, so that's awesome. Let me try to submit this. Cannot today. Come on. Okay. Okay, so we beat about 42% people. Well, it accepted. That is a big deal for me. And it beat just about 42% in time. Okay, that is interesting because I mean the linear time approach is really fast. I wonder if we are doing like one extra calculation or something, and that probably is what is keeping us, not that high in time. But I think the algorithm is still very clean. It works, and if maybe a lot of people submitted like really compact implementation, I don't see any extra stuff that we are doing here, honestly. So yeah. Hopefully that was instructive to all of you. If you're liking what I'm doing on this channel, please consider subscribing to my channel, and please hit the thumbs up button on the video if you can. See you guys next time.